Good day, everyone. Today we are looking at differentiation. Now, differentiation is the first part of calculus. Now, when you hear calculus, generally, calculus is what is now divided into differentiation and integration. So when you say calculus, you are talking about differentiation and integration. And of course, another name for integration is anti-differentiation. Anti-differentiation. So that is why you are expected to learn differentiation first before you learn integration. Why? Because when you are solving question on integration, you are going to be differentiating some things. So, but today we want to focus on differentiation. And now, differentiation, of course, has other names. You can also call it derivative. You can call it slope. You can call it gradient. You can call it change in y over change in x. You can call it rate of change. You can also call it dy dx. So, if you are given a question and they did not say differentiate, they can use any of these words and they still mean the same thing. Okay? Having said that, what's differentiation all about? Now, you know, if I have 2 is equal to 2, this means that this side is equal to this side. Now, but the moment I add 1 to this place, you know, this side has become 3. So it's no longer equal to this side. So because this side has changed, this side too must change for them to be equal. So differentiation is about change that happen to one side as a result of change in another side, in the other side. So that is what differentiation is all about. And then you must have an understanding that when we are talking about differentiation, if I have y at my left hand side and x at the other side, so what I'm going to be looking for is dy dx. But let's say I have p and then I have t at the other side and I want to differentiate. What I'll be looking for is dp dt. So what this is saying is that change in y as a result of change in x. This is change in p as a result of change in t. So that means if I have m and k at this other side, what I'll find is dm dk. That is change in m as a result of change in what? In k. Okay, having said all of this, now what we are going to be looking at in differentiation will now consist of first principle. You also call it central limit theorem. And then we are going to be looking at rule 1. We'll also look at rule 2. We'll also look at composite rule or function of function. Or chain rule. You can call it any of the 3. Then we're also going to be looking at product rule. Then we'll also look at quotient rule. Then we'll now look at higher derivative. So we'll also look at logarithmic function. we will look at exponential function. Then we will look at trigonometric function. And then we will look at application to economics and business. So all of these are what we are going to be considering in differentiation. We are going to look at the first principle. We are going to look at rule 1, rule 2, composite rule, function of function, or chain rule. You can call it any of the three. Product rule, quotient rule, higher derivative, logarithmic function, exponential function, trigonometric function, and application to economy and what? Business. So we are going to be looking at differentiation in this order. So the first one we will start with is the first principle. So okay, now we want to look at first principle or central limit theory. Now let's assume that you have example 1. You have given y equals x squared. Differentiate with first principle. Now, at every time they want you to use first principle, it will be stated in the question. Now, if they don't say first principle, don't forget they can say central limit theorem. They say using central limit theorem. Now, if you want to solve this question now, solution. Now we have y equals x squared. So from here, now I can decide to start from this side. Let me divide the board into 2. Now I have y equals x squared. This is what I have. Now the first thing I'm going to do is to say, okay, y plus change in y. This sign means change. It is a Greek sign. You call it delta. Delta, capital letter delta. Now you have this sign as delta. You also have this sign. So capital letter delta, small letter delta. That's why if you are solving question on first principle, you can use this or this. So what I'm saying is that I can say y plus change in y instead of using this, but it's the same thing. So but I want to stick with this. Now I will now say y plus change in y equals to, so because this side has changed, then x plus change in x, and because it has squared, you put square here. You see what I did? So it's like saying y plus change in y is equal to x plus change in x, then you put the square. You see that? So then the next thing we have y plus change in y equals x plus change in x into bracket x plus change in x. Now because this one is having square, it means this thing in 2 places. So this side still remains the same. Okay, so the next thing I'm going to say is to say y plus change in y equals, so you have to expand this bracket now. So expanding this bracket, you are going to have x times x. That will give you x squared. Then x times change in x. That will give you x change in x. Plus change in x times x. X change in x. Then plus change in x times change in x. That will give us change in x squared. You see that? So what I did was to say x times x, x squared. Then this x again times change in x. That's x change in x. Now some of you might be thinking, why is it that x times change in x is not change in x squared? No, because this change in x is together. You can't separate the x from the change, and so this x will only multiply it. So x times x is x squared, x times change in x is x change in x, then change in x times x, I will have this x change in x. You can't multiply this x together, I've told you that. Then change in x times change in x, that will give you change in x squared. You see that? So from here, I'm going to say y plus change in y equals x squared plus, this is x change in x, this is x change in x. By the time you add it together, that is 2x change in x. You see that? X change in x change in x in two places. That's why you have 2. Then plus change in x squared. You see that? Why I'm putting it in brackets is because I want you to know that the square affects both the change and the x. You will not just put square without putting the brackets. That would be wrong. So now that you have done this, now the next thing you will now do is to say make y the subject, make y the subject of formula. That is, you want y to stand alone from here. So what that means is that this plus y will cross over to the other side, and the moment this change in y crosses over to the other side, this plus will change to minus. So if I want to write that, I'm going to have y equals to, I will still write all this, x squared plus 2x change in x plus change in x all squared minus change in y. You see that? I wrote everything at this side first. Then this plus change in y, bringing it here, it will change to minus. So I will now say recall that y equals what? X squared. Recall that y equals x squared. Okay. Now, from here, look at this place very well. Look at this place very well. So from here now, you are going to make change in y the subject of formula. You are going to make change in y to stand alone. So I can say make change in y the subject. Make change in y the subject. So when you make change in y the subject, so that means this y is going to the other side. So I'm now going to have change in y equals x squared plus 2x change in x plus change in x all squared minus y. You know this y that you have here is having invisible plus. By the time it crosses to the other side, it will change to minus. Then this change in y is still at this other side. So you are leaving this change in y here, but this y is coming to the other side to come and change to minus y. So then from here now, you are now going to say recall that y equals x squared from the question. You know in the question they say y is equal to x squared. So what this means is that anywhere you see y, you are going to put x squared there. So you now have change in y equals x squared plus 2x change in x plus change in x all squared minus x squared. That is, instead of you to write y, you have written x squared. Why? Because y is equal to x squared from the beginning. So here now, this x squared will cancel this x squared because this is plus x squared, this is minus x squared, so it will cancel out. So I'm going to have change in y equals 2x change in x plus change in x all squared. You see that? So from here now, I can now say change in y equals, what is common? Change in x is here, change in x is here. So bring out the change in x and open the bracket. you will be left with 2x plus change in x. You know, in mathematics, you must know that if I have 2x plus 4, then I say 2 is common. Whatever I say it is common, if I bring it out, I will use it to divide. So if 2 cancel 2, I will bring down x. Plus 4 divided by 2, that will give me 2. That's how to collect, that's how to factor out. So here now, I said change in x is here. Change in x is here. Let me bring it out. So I will use this change in x to divide both sides. So if change in x cancel change in x, I will be left with 2x. Change in x will cancel 1 out of these 2, it will remain 1. That's why you have this. So I expect you to pause the video, write down this place, because I'm going to clean this side now and to continue. Okay, so having said that, I'm now going to have so from here I will now say that change in y equals change in x into 2x plus delta x. So divide both sides by change in x. So you are now going to have change in y over change in x equals change in x into bracket 2x plus change in x over change in x. Now what I did is that I use this change in x to divide this side and also this side. That's why you have it. So by the time this cancel this, so I'm going to say change in y over change in x is equal to 2x plus change in x. You will now say that as change in x tends to 0, that is, you will say let this change in x be equal to 0. That's what we are trying to say. Then this one will now change to dy dx. So that will now be 2x plus, anywhere you see change in x, put 0. So 2x plus 0. So the final answer will now be what? 2x. That's your final answer. So if you are asked to differentiate y equals x squared, y equals x squared, your answer is 2x. Of course, this is first principle. So this is what first principle is all about. Now I want you to look at this video very well. If you don't understand it, watch it again, and then if you are still finding it difficult after you have watched it twice, get back to me through the number on the screen. But I want you to try this and then get back to me. Y equals x raised to power 3. Differentiate with first principle. Differentiate with first principle. And that will be my assignment for you. In my subsequent classes, I'm going to be starting with the rules of differentiation. I'll talk about rule 1, I'll talk about rule 2, and then I'll talk about all other rules. Thank you.